Okay, Algebra 2B people, how you guys doing? Today in this video, this is for the whole week, one video for the entire week. We are doing lesson 4-3, as it says right there, and it's about dividing polynomials. In the previous lessons, going all the way back to when we were in school, we did adding polynomials, subtracting polynomials, multiplying polynomials, and then the assignment you did last week on Pascal's triangle is also about multiplying polynomials, but many of them in a row by using that Pascal's triangle shortcut. Today we talk about division. Now there's two types of division, long division and synthetic division. In Algebra 2, we teach the synthetic version. And if you move on to farther math classes like pre-calculus someday, we teach long division. Now, it's going to be a much abbreviated version of what we do compared to what we do in class. So just kind of follow along. I'll try to talk as carefully as I can and give you all the details. And like I said, the nice part about some of this is you can pause, back up, watch it again, because there are some just piddly details to work with. So in this first question, I've got 3 examples total. I got 2 of them up here already. The first example we're doing x cubed minus 11x squared plus 22x plus 40 divided by x minus 5. Now, I've specifically chosen examples, and your assignment will reflect this. There'll be no remainders. You understand when you divide, not everything divides perfectly. You know, like you could be like, well, 12 divided by 3 is 4. Well, what's 13 divided by 3? Not exactly 4. You know, it's 4 with a remainder. So these kind of problems have remainders also. But because of the special circumstances, we're only going to do problems that have no remainder. That way, you'll kind of have a good idea if you did it right or wrong right off the bat. Okay? So, let's talk setup. How do you set this up? First of all, you make this long kind of L-looking bracket. Well, I don't like the way that looks in the camera. And when you do these divisions, you only work with the coefficients, which are the numbers in front of the x's. So like the number in front of, and you do it in order. So there's an understood 1 here. That's negative 11, that's 22, that's 40. So those are the numbers. So when you do this on a notebook piece of paper, possibly, this should be one line of notebook paper, and this should be the other line of notebook paper. Okay? So here you put the numbers 1, negative 11, 22, 40, representing 1x cubed. Negative 11x squared, 22x, 40. Now here's probably the trickiest part for everybody. Whatever this says, x minus 5 in this case, whatever that number says, use the opposite sign number and put it out front. So that says minus 5, put a 5 out there. Okay, now here's what's known as the synthetic division process. Now you have the problem set up. That's what it should look like. Every time, the first number in the bracket here, drop it down below this line. So this 1, put a 1 down here. Numbers that fall here, multiply to the number out front, and you move it up under the next number. So 1 times 5 is 5. Move that up here. And you always, in synthetic division, you add the 2 numbers. Okay? So negative 11 plus 5 is negative 6. And that addition goes here. Any number that falls below the line multiplies to this number out front. Negative 6 times 5 is negative 30. Move it up and over. And add those 2. 22 plus negative 30 is negative 8. Soon as the number is down, multiply. Negative 8 times the 5 negative 40. Add those two. 40 plus negative 40 is 0. I always separate that last number. That last number represents the remainder. That means for this assignment, for the 3 examples that I'll do in this video and the 5 problems you'll get on your worksheet this week, that number should be 0 every time you're finished with the problem. Now, last thing is to write the final answer, because, you know, the original question had x's in it. Your final answer should have x's in it. This 1 came from this 1x cubed. When it drops below the line, it loses an exponent value. So when this was 1x cubed, when it came to here, it's 1x squared now. So this answer is 1x squared minus 6x minus 8. That means, now think about, remember earlier at the start of the video I said, you know, some things have a remainder, some things don't. 12 divided by 3 is 4. You know what that means? 3 times 4 is 12. This divided by this is this. That means this times this would give me this. And it will. Now I'm not asking you to check that, but that's how it works. See how 1x cubed, 1x squared. And everything goes down. X squared, just x, just number, done. Okay, now that's the first time you saw that explanation. Now you're going to re-see it with a new example. Very similar example. You'll see how it works. So starting with these numbers, that's a 1x cubed, a minus 13x squared, a positive 24, and a positive 18. There's the coefficients. This says x minus 3. Minus 3. Use plus 3. And start the synthetic process. Which means first number in the little bracket, drop it. Drop it right down here, 1. Multiply. 1 times 3 is 3. Move it up and over. Add those two numbers. Negative 13 plus 3 is negative 10. Multiply. Negative 10 times 3 is negative 30. Move it up and over. Add those two. 24 plus negative 30 is negative 6. Negative 6 times 3, negative 18. Add 0. 18 plus negative 18. As I told you, for this situation, because we're just not in class together, that number should be 0. And then lastly, write your answer. That stood for 1x cubed when I wrote it. The minute it fell to this level, it's 1x squared. 1x squared minus 10x minus 6. And that's the second example. Now, I'm going to pause, erase this one over here, and do a final example. So let me pause a second. Okay, so for our final example, I wanted to do 2 things with it. Number 1, I wanted to actually have a different number on this x cubed other than just a 1x cubed. Like this was 1x cubed and the example 1 was 1x cubed. And then secondly, I wanted to make sure that one of the divided by was an x plus, because the first 2 examples were x minus. So I just wanted to make sure I address that and see that. And by the way, they don't all have to be, you know, x cubed, x squared. It can be any size. It can go from x to the 4th to x to the 3rd to x to the 2nd. Again, we're just trying to keep it kind of basic because of the situation. So let's set it up. Two for the x cubed, 9 for the x squared, 2 for the x, minus 21 for the number. You are dividing with x plus 3. It says plus 3. You use minus 3. And we go through what's known as the synthetic process. It hasn't changed. It'll be identical. So whatever the first number inside the little bracket, drop it down here. So this is a 2, drop a 2. Whatever drops, multiplies out front, move it up and over and add. It's the same process. So 2 times negative 3 is negative 6. 9 plus negative 6 is positive 3. 3 times negative 3 is negative 9. 2 plus negative 9 is negative 7. Negative 7 times negative 3 is positive 21. Negative 21 plus 21, 0. Once again, every problem you do in the assignment, including the examples, must say 0 here. Okay? So that's the case. And then we write our final answer again. Now remember, when we wrote this original 2, it was 2x cubed. The minute it fell down to this level, 2x squared now. It goes from an x cubed to an x squared. So this is 2x squared positive 3x minus 7. So that's that. Okay, your assignment is going to be another 5 questions that you'll do on, if you feel like printing the worksheet and doing it right on there and snapping a picture and uploading it to Google Classroom, or just do it on separate paper like a lot of you did last week. That worked really well. And do the same thing. You don't have to print it out on paper, especially if you don't have a printer or something. Just do it on paper and submit it. Okay? Hope you guys have a good week and you're staying safe and you're staying healthy. Take care.